right, we're going to take a look at this example 5 here. All we're doing is graphing the circle, and to do that you need to know the center. So I'm going to put C for center and the radius, so R for radius. And down here at the bottom I'm going to write our generic equation that we had before, x minus h squared plus y minus k squared equals r squared. And so we compare our equation to the original. So the original has x minus h, ours has x minus 3. So that must mean that the number we plugged in for h is 3. So the x-coordinate of my center is 3. And then we keep going down here in the generic, it says y minus k squared. Well, up here in our equation, we have a y minus 5 squared. So that must mean that the number we plugged in for k was 5. So that means our y-coordinate of the center is 5. And if you take a look, your first instinct is not to say 3, 5 is the center. Your first instinct, if you're just looking here, is to say -3 and -5. And the reason that they're positive is because this minus sign is part of the generic equation. So when you're trying to find the center of a circle, it normally looks backwards from how you think your final answer should. Like at the beginning, you think, oh, it's going to be -3, -5. But because this minus sign is in the equation, it's really 3, 5. And so then we take a look. The end of this is r squared. So this 4 is the r squared. So we're going to have to square root, which means the radius is 2. So what we're going to do is we're going to plot the point 3, 5. So over 3, up 5. There it is. And then we're going to go from that point, we're going to go up 2 and put a dot, because our radius is 2. And then we're going to go back to this green dot that I have, that 3, 5, and I'm going to go to the left 2 and put a dot. And then I'm going to go back to my center, that 3, 5, and go down 2 and put a dot. And then finally, I'm going to go from the center left 2 or right 2 and put a dot. And then I'm going to connect these blue dots kind of in a circle-ish shape. Again, it might not be perfect, but it's a pretty close looking circle. So we're not going to do example 6. I want you to try that one on your own. Be careful of these, that minus sign right, or that plus sign right there, because your generic equation has a minus sign in it. So just be careful of that when you do it. So pause the video and try example 6. Okay, so you should have tried example 6. Now we're going to do this example 7 together. So we're going to keep in mind our generic equation of a circle, x minus h squared plus y minus k squared equals r squared. And we're just going to write the equation, but this time it's based on the picture. Lucky for us, this dot in the middle, that's the center of the circle. So this dot is at 1, 1. That means my center, 1. That means the center of the circle is 1, 1. And then the radius, we're just going to count. So count from the center down to a dot, 1, 2, 3, 4. So your radius is 4. And then we're going to plug these things in our generic equation. So we're going to have x minus h is the x coordinate of my center, which is 1. So we're going to have x minus 1 squared, and then plus y minus k is the y coordinate of your center, which is 1. So y minus 1 squared equals, and then the radius squared. So 4 is your radius, so 4 squared is 16. There is your equation, all nice and pretty. So that's one way you can write the equation from a picture. And the last thing we're going to do in this video is this example 8. This is a different equation of a circle. It's still a circle. It's just not the equation that we're used to. Okay. And it says, what's the radius? What's the center? There is a crazy long algebraic way to do this, but Desmos will do it for you. So what I'm going to open up a Desmos window in my computer, and I'm going to type this equation in, and then we'll be able to see what the radius is and what's the center. So let me go to Desmos. Okay, so I've opened my Desmos window, and now what I'm going to do is I'm going to take that equation, that crazy looking one, and I'm just going to type it in Desmos. So here it is, x squared plus y squared minus 10x plus 8x plus 16 equals 0. So I'm going to type all that in Desmos. So x squared, I think it was plus y squared. I should probably make sure. Yep, plus y squared minus 10x, oops, plus 8y, I'm just double checking, yep, 8y plus 16 equals 0. And hopefully you can see that it started to make a circle. I'm gonna drag my Desmos, there it is. So there's what the circle looks like. And hopefully we can kind of eyeball where the center is. I'm gonna zoom in, oh gosh, maybe not that much. This would be 5. So the center of my circle, I think. So what I did, I know this looks different than my previous screen. What I did is I zoomed out and I put a dot where I think the center of the circle is. So I think that the center of my circle is at 5, -4. You can kind of see that in my window. So that's this green dot that I put. And then to double check, you would just count from the center, like to the top, the bottom, the left, or the right, and make sure that those are all the same distance, and that will be the radius. So from this green dot out here is 1, 2, 3, 4, 5. So that's good. And then from the center up is 1, 2, 3, 4, 5. Cool. From the center over to the left, 1, 2, 3, 4, 5. Awesome. I'm just counting the lines. And then from the center down, 1, 2, 3, 4, 5. So they're all 5. So that's the center of my circle, and the radius is 5. So this is still a circle. The radius of the circle we counted was 5. And the center, oops, hold on. So radius is 5, and the center we eyeballed is 5, -4. And again, if you put a dot where you think the center is, and then once you put a dot, you can and zoom out, you can kind of tell if it's in the center or not. Like you can kind of eyeball that without too much trouble. So Desmos will graph this thing for you, so that's awesome. And then you can tell what the radius in the center is pretty much just by counting.